Okay, guys, we'll get started. Um, so I don't know if you noticed, but we're going to be doing math today. So hopefully you brought along like a graphing calculator or something you can use. Um, and then for the most part, you don't necessarily need a calculator today, so you should be good if you don't have one. But if you do have one, it'll help. So what we're going to be covering is basically just like some geometry, important terms and rules and stuff. So if you have, I think it should be in like your materials, but this like math packet that Manoj gave you, it's got kind of like fireworks on the front or something like that. If you have that math packet, do you want to flip to page 1? We'll kind of be working between pages 1 and 2 today. And so, yeah, we'll be going over like, it's not really kind of notes, I guess, but more examples. So if you want to like write those down in your notebook or something, and then you can look back on those later. Before we start, a couple things I want to mention. For you guys that are like inside, at the end of class, if you could like pick up your chairs and like fold them and like set them against the wall out there, that would be really helpful. Just because you have to put them away at the end of the night. And then for everyone, I think Manoj should have sent out like the homework assignments for like each class or each session or something. So make sure you're doing those. This is just like a reminder to do the homework because that's going to be really beneficial in the long run. Yeah, that's everything I wanted to say. So if you have your math packets, hopefully everyone has those. I'm going to give you like a couple minutes to just like flip through pages 1 and 2 and kind of look at what we'll be doing today. Okay, so I guess we'll get started. But we're going to start off talking, it's like right at the top of the packet, talking about lines and line segments. So I'm sure you guys know like what a line is, what a line segment is. So for like us up here, we're going to start talking about something called the segment addition postulate. So I'm going to draw a picture up here. So here I've got my line, and then my line set. I put points on there, so then I've got my segments. But basically what the segment addition postulate says is that if B is between A and C, then AB plus BC is going to be equal to AC. So I'm going to kind of draw an example. But from there to there is AC, and so our segment addition postulate is saying that AB plus BC is the same as AC. Kind of self-explanatory, but yeah, so the two parts are going to add up to the whole is what it's kind of meaning here. So hopefully if you guys can all see on this, I'm going to draw an example that we'll do. So say they give you like a question like this on the ACT. Or they give you a picture like this, it's kind of like a segment, and they say find DF. Well, to find that, all we have to do is add together DE and EF. So someone ought to like yell out what the answer is.
58.
Yeah, 58. And then I didn't say like feet or anything, so we'll say like units. 58 units. Okay, so we're gonna do one more example, but this time you guys are gonna do it on your own. If I draw it down here, can everyone see? Okay. So. Okay, so the question is to find GH. I told you that FH is 36 and FG is 21. Okay, does anyone have an answer?
15 units.
Yep, 15 units. So GH is equal to 50. Okay, so that's the segment addition postulate, and you could see maybe just like one question on it or anything like that. But that's how you do those ones. Okay, so now what's next in your math packet I think is angles, and we're going to be talking about, I think it's angles. Yeah, we're going to be talking about angles now. So first, just like a little vocab lesson. But say I have an angle like this. There are like 3 different ways I can name this angle. Do any of you guys know like how I could name it? Do you have one?
I was gonna say acute. I don't know if that's what you're talking about.
Oh yeah. Well, that's also correct. But I meant like the name of the angle using the letters.
PQR.
Yep. Okay. Does anyone have another one?
IQP.
Yep. Oh, sorry. Someone online say something? I'm sorry, the volume's down. You want to repeat it?
I was just giving the name, but I got it. It's good now.
Oh, okay. There's one more. There's one more, guys.
Q.
Yep. Angle Q. So we could either go like from left to right, or we could go right to left, or we could just call it by the name of the vertex. So there's 3 different ways we could name an angle. So if you do see like any of these, you'll know which angle they're talking about if there are multiple. And then along with that, there's like 4 different types of angles. So I'm gonna write them all just like here. And I think they're listed in the packet too. But here are the 4 types of angles. So we can have an acute angle, which is less than 90 degrees. A right angle, which is exactly 90 degrees. The obtuse angles are greater than 90 degrees. And then we have something called a straight angle, which is 180 degrees. Okay, so we just talked about the segment addition postulate, and then we've got something called the angle addition postulate. So again, I'm going to draw an example. So for this one, my ray, like from S to P, is in between angle RST. And so these two like smaller angles should add up to my larger one, is kind of what the angle addition postulate says. Yeah, so we're going to do an example. Does everyone have all this down? Yeah. Okay. But I'll see if you guys can, or actually, okay, we'll do this one together, and then the next one I'll give you guys your own. Okay, say this was like a question, and they told us that angle LKN is equal to 145 degrees, and then we're supposed to solve for x. So LKN is kind of like that whole angle, and we know that LKM, this like smaller one, is 2x plus 10 degrees, and then the larger one is 4x minus 3 degrees. So according to our angle addition postulate, we should be able to write an equation that can solve for x. And so what we're going to do is add our two smaller angles together and set it equal to 145. So I'm going to write 2x plus 10 plus 4x minus 3 is equal to 145. And then I'm going to combine like terms, so 2x plus 4x, 6x, 10 minus 3 is positive 7 equals 145. Then to go along further, I'm going to subtract 7 on both sides. So 6x is equal to 138. And then if I divide by 6 on both sides, for x I should get 23. You guys agree with that? Okay, so then that's the value of x, and then if they went along further and they said find angle LKM. So that's this smaller angle right here, and now that we know what x is, we can actually plug that in and then find this angle. So 2 times 23 plus 10, and we should get 56 degrees for that one. All right, any questions so far? No? Okay, so I'm going to erase. Does everyone have the work down? Okay, everyone online? You're good? Okay, so I'm going to write one more, and this one is for you guys to do on your own. so everything you need should be up on the board to solve that one. But I want you guys to solve for x and then tell me the measurements of those actual angles. Okay, does anyone have an answer?
Angle EFH is 60 degrees.
And then did anyone find HFG? 30? Yep, 30 degrees. Alright, does anyone have any questions about how we got there? Or how we should have gotten there?
Yeah, can you just write out the equations?
Yeah. So because we know that EFG is a right angle, that's the total, we know it should be equal to 90 degrees. So I'm gonna write over here. But I would do 2x plus 2 plus x plus 1 is equal to 90. And then from there I'm gonna, like last time, combine like terms. So 2x plus x is 3x. 2 plus 1 is 3, equal to 90. Subtract 3 on both sides. 3x is equal to 87. And then for x, you should get 29. And then from there, you'll plug into like your original expression. So 29 into 2x plus 2, you should get 60. And then 29 into x plus 1, you should get 30. Alright, so... Okay, now we're going to be talking about, if it's at the bottom of page 1 in your packet, but the complementary and supplementary angles, and then a couple of others. Okay, so complementary angles are two angles whose measures have a sum of 90 degrees. And so if I were to draw an example, my two angles here form a right angle, so they should be complementary because their sum is 90 degrees. And then also they don't have to be right next to each other. So I could have, say, like an angle here that's 40 and then another angle here that's 50 degrees. And so because they add up to 90 degrees, they would be classified as complementary. And then my supplementary angles are two angles whose measures have a sum of 180 degrees. So to look at that, I could have something looking like this, and then again, they don't have to be next to each other, so maybe like 80 degrees here, and then 100 degrees there. Something that like supplementary, I guess like the S sound, supplementary kind of sounds like straight line. Usually my supplementary angles are forming a straight line, kind of like this one we have here. So that's just how I remember those. The supplementary forms a straight line, and then I guess the complementary doesn't. But yeah, so it's important to know complementary is 90 degrees, and then supplementary is 180 degrees. And then along with that, we have adjacent angles. And those are okay, so my adjacent angles are two angles that share a common vertex and side. But the thing is, they're not going to be like right on top of each other, they're going to be next to each other. So those are my adjacent angles. And then the last one are vertical angles. And those are, the definition's kind of weird, but two angles whose sides form opposite rays. Another thing is that the angles are they're actually just like opposite of each other. So 1 and 3 are going to be a vertical angle pair, and then 4 and 2 are going to be vertical angles too. Oh yeah, and then something else was mentioned. Vertical angles are congruent. So that'll be important. I'll start over here. So we're gonna do an example, not really example, kind of just like a math problem. I'm gonna see if you guys can do it on your own. Let me write the question. Okay, so from this figure here, I'm going to ask you guys to try and find A, B, and C, and what they equal. And then this little symbol here, if you don't know, it means that this angle is the same as this angle. It means that they're congruent. So hopefully with what we've just been talking about, can you guys try and find A, B, and C? Okay, so for A, you should have gotten 68 degrees. B is 112 degrees. And then C is also 68 degrees. Does anyone have any questions about the answers or how we got the answers? Okay. Okay, now we're gonna do kind of like another challenging one or one similar to that, but it's gonna be a little harder. So. Okay, so here's my figure, and I'm gonna have you guys find A, B, C, D, and E. Okay, we'll kind of start talking through this one. But what did someone get for A?
90.
Yep, 90 degrees. And that's because it's supplementary with this right angle right here. What about B?
90.
Yep, also 90. You could prove it by saying that's a vertical angle with our 90-degree angle. Also supplementary to A. Okay, what about C?
42.
Yep. Yeah, so C is supplementary to this angle right here, 138. So to find it, 180 minus 138, and you should get 42 degrees. What did somebody get for D?
48.
Yep, 48 degrees. Kind of the same concept, but 180 minus 132 because those two angles are supplementary. And then what about E?
132.
And so for that one, it's because it's a vertical angle with the one that they told us about. Okay, good job. Let me erase this over here. So now another one, kind of what we've been talking about. I'm going to throw in some variables though. So okay, so I'm going to have you guys find both X and Y. And so this one, I'll give you a hint, it deals with the vertical angles. Okay, so for this one, y is super simple to find because it's a vertical angle, and so we know it's automatically 168 degrees. X is a little bit harder, so we're gonna have to write an equation, and so we'd set them equal to each other. X is equal to 5x minus 48. So I'm gonna subtract my 5x over. And so we've got negative 4x is equal to negative 48. And then I'm going to divide by negative 4 to get x alone. So x should be equal to 12 degrees.
I have a question for that
Yeah.
one. Could you also just do since x and like the 168 are supplementary, could you just do 180 minus 168 to get
Oh.
x?
Yeah, that's a good point. You could do that too. Whichever way is like faster for you, because remember, like the test is timed. So if that way goes quicker for you, then definitely go for it. But yeah, you get the same answer. X would be 12. Okay. I got another one for you guys. This one shouldn't be too bad. But I want you to find the measure of B. Alright, does someone want to call an answer?
27.
Yep, 27 degrees. And so for this one, those two angles are complementary. They form a 90-degree angle, so just 90 minus 63, and then you're done. Okay. One more of this type for you guys, and then we'll move on to another topic. Okay, so again, kind of like the other one, we're going to solve for x and y. Okay, does anyone have an answer for x and y?
For x, I got 16 degrees.
And y?
10.
Okay, any questions about how we got there? now we're gonna move on. It's on page 2 of the math packet. I'm gonna talk about parallel lines. So it defines parallel lines in there. Lines that are, what does it say? Lines that never meet. They're never gonna intersect. And then let me draw some. So here are my parallel lines, and then if I were to draw a line through it, this line would be called the transversal. I think it also says that in the packet, but it's a line that intersects 2 or more lines at different points. So it's intersecting like here and here, and then these are my parallel lines. So if I were to label just like the angles, we've got some different things that go along with, I guess. We're just gonna classify some of these angles. So first, angle 2 and angle 6 would be called corresponding angles, and that's because, like, in relation to each other and the transversal, they're sort of in the same spot, if you can see that. Okay, and then angle 4 and angle 5, that's something called alternate interior angles. And so with that one, they're on opposite sides of the transversal, but they're both like kind of on the inside of our figure, if that kind of makes sense. So those two would be alternate interior. And then also we could say 3 and 6 are alternate interior. And then I didn't mention it, but there are more angles that correspond with each other. Those are just, that was just my example. And then angle 1 and angle 8, those could be classified as alternate exterior. So again, they're on opposite sides of our transversal, and then they're more on the outside of our figure. And then 7 and 2 would also work for alternate exterior angles. The last thing I'm going to mention is something called consecutive interior, and that would be angles 3 and 5 or angles 4 and 6. So consecutive interior. And so then when we have a transversal, like splaying 2 parallel lines, we actually have some properties with these angles. So corresponding angles are going to be congruent. Sorry, I didn't really leave room for that. They're congruent. Our alternate interior angles are also congruent. Alternate exterior angles are congruent. And then consecutive interior angles are supplementary. So remember that meant they add up to 180 degrees.
Wait, what's the little congruent sign again? What does that look like? I can't remember.
Is it like the,
It's got like a squiggly line, I know that, but I don't remember if they're doing it.
is it like the equal sign with
yeah, and then
the squiggly on top?
Sorry,
Okay.
I just wanted to know.
So someone asked a question about the congruent side. We agreed on this.
Sorry.
Yeah. Hopefully you don't see that because I didn't confirm or deny.
Sorry, my bad.
Okay. So does everyone have this down? Yes. Okay, I have a fun challenge for you guys. I'll erase that later. But it's gonna take me a while to write it on the board, so you can just chill for a minute. Okay. So hopefully you guys can see all of those, but there are 20 different angles that I'm going to have you guys try and find. A lot of them are the same, some of them are different. And then what I did tell you is that line L and line M are parallel. That's like the parallel symbol. And then the measurement of angle 1 is 35 degrees, and the measurement of angle 12 is 111 degrees. So I gave you 2 angles, and I'm going to have you guys find the other 18. And then while you guys do that, I'm going to grab my water bottles. Okay, we're gonna start going over them. It's okay if you haven't finished yet, but I don't want to like write them all on the board, so I'm gonna have you guys like yell out the answers as we go if you have them. So for angle 1, so it should be easy.
35,
Yep. What about angle 2?
145,
3.
111.
Yep. 4.
69,
5.
111,
6.
69,
7.
145,
8.
35,
9.
69,
10.
111,
11.
69,
12.
111,
13.
69,
76.
Yeah, 76
76,
for 13. 14.
104.
15.
76.
15 should be. Oh no, yeah, you're right. 15 is 76. Sorry. Okay, 16.
104.
17.
104.
Oh wait, did I just say that? Okay, sorry. 18.
76.
19.
104.
And then 20.
76.
Okay, so could you guys online? Could you hear the answers?
Could you repeat 15 and 16?
15 was 76, and then 16 was 104. Any other questions? Okay. So we're gonna do just one more thing. If hopefully everyone has
What was 19?
Oh, 19? 19 was 104.
Okay.
Okay. We're just gonna do one more thing with area. So if you have your math packets, kind of like at the bottom on page 2, near the bottom, it says under the quadrilaterals heading, it says the general form to calculate area using diagonals for quadrilaterals is area equals D1 times D1, or D2 divided by 2. So this is the equation for finding the area when you know like the diagonals of a quadrilateral. And I've seen a question like this on the ACT before. They ask you to find area and you like don't know the length and width or whatever, you just know the length of the diagonals. So we're gonna do just one example real quick. Say I had a rhombus right here. And then I know that one diagonal is 21 meters, and then the other one is 17 meters. So plugging into that area equation, can you guys find the area of this quadrilateral? Okay, so to solve this one, I'm going to do 17 times 21 divided by 2, and you should get 178.5. You guys agree? And then the label would be meters squared for that. Okay, so it's 7:25, so you guys get to go on your 10-minute break. So that's all we're gonna do today for the geometry stuff. But you guys can, like, if you have snacks or like water, and then you can chat everything.